Get your PCX, please. Hello. What's your PCX? Nobody's interpolating. 52. All right. Step 9. I've already I've already done it for you so that you not take time. Hello, one house. If you know you don't want to do anything, just step out now. Let people down to learn. We're almost done. I beg. Me too, I'm tired. Step 9. What's step 9? Step 9. So let's do that. What clause are you using? 4.7.4. So PCX now will be what? AG PCX. Then PCY will be AG PCY. All right. So let's get our PCX and PCY. 3402 is what? So PCX is what? 3402 kilonewton. All right. So what's our PCY? 2085 kilonewton. So which one will now be your PC? But then you are not checking anything, so you are not using that thing. So what's the next step? This one, did he tell you to pick? The reason why you sorry, the reason why you picked the last one because you wanted to do one check. FC is less than PC. So you have to pick the lower one as the PC, right? But this one, you are not doing that FC is less than PC. That's what you check in this case. Now, you need to know these steps in your memory because it brings it out as test. It will just tell you for axially loaded members, write out the design steps. So you write it step 1, you do this, step 2, you do this, step 3. Apart from solving, yes, there are theory questions. You ask you to write out design steps. So now, the next step is what? Buckling resistance. Now, for you to get that buckling resistance, are you with me? For you to get buckling resistance, go to table 26. Table 26. Table 26. Now, table 26. What this table 26 is saying is, normally, when you are given, if you are given a question like this, in some cases, are you listening? When they give you a column like this, in some questions, they will tell you what the moment is on top, what the moment is at the bottom. But in this question, they didn't tell us that, right? In this question, they told us that. They only told us our moment at the major axis and the minor axis. What this table 26 is saying is that in cases whereby they give you a moment at the top and at the bottom, you divide it by each other. Are you with me? To get your beta. Look at that table 26. Are you with me? you see a moment on top and at the bottom. To get your beta, you have to divide the one at the bottom by the one on top. But the way he brings out his own question, he doesn't give us that moment. So because this one, we don't have any moments. How we know we don't have any moments is if he tells you a factored, look at that your question. Read your question for me. So that factored there is telling us that they factored in some things. This is the particular thing that they factored, that moment. So now we are taking that moment as one because it's not given to us. So there's nothing to divide anything. So we are just going to take our beta as what? One. Are you with me? If you go to Redbook, I sent Redbook to people. If you go to Redbook and you open this particular topic, you can actually check it later. I just can't take that example. It's another long step again. There are cases whereby they will give you moments on top and at the bottom. That effect will be in this table 26. You have to divide it by each other. You most likely not get 1.0. You know this one is the whole number. You most likely interpolate 2 in this case. Are you with me? But in this question, they did not give us a moment on top and at the bottom. So we are assuming that they factored it. So we are assuming it is the same. So if they say x divided by x, what will you get? 1, right? Factored, we are assuming the moment on top is the same thing as the moment at the bottom. So anything, x divided by x is equal to what? 1. A value divided by the same value give you what? 1. Are you with me? Do you understand what I'm saying? So our beta here will be what? So our m will now be what? I don't know how to explain to you if I'm not using a question that actually has this. So maybe in the next class, or I'll give you as assignment so that you can actually study. Is in the answer is in, if you like drop the answer. The answer is in Redbook. So now that m, we'll take that m as our mx and our my. Since beta is equal to what? 1. So it will give us what? 1. Are you with me? How is our beta 1? Were you sleeping just now? Oh. We'll come back to it. We'll come back to it. You were sleeping. Wow, well, we'll come back to it. Now, for you to check your buckling resistance, the last step, go to clause 4.8.3.3.1. I think I gave you that. What step is that? 4.8.3.3.1. Now, write out the formula you have there. The formula you have there will be something like this. We'll come back to it. We'll come back to that step. I think the way he arranged it was faulty. So the formula is FC over what? PC plus MX. Can you see that the MX, they are different? This one is small letter. This one is capital letter. The way where you get this MX from is from this beta. From table 26. From table 26, our beta is 1. So our corresponding M value is what? 1. And I said that 1. That M is same thing as MX and MY. The way our LE was what? Our LE was what? And our LE was what? LEX and LEY. That's the same thing in this case. Our M is equal to 1. And eh? Yeah, small m. This is small m. So this small m, capital letter M. If you have factored, if your question says factored, all right, so let's do this. What's our FC? Why is it times 10 power 3? What's the unit of our PC? What's the unit of our PC? Kilonewton. Now, our PC, Our PC, what would not be the value of our PC here? You know this place, they said what? PC. So what will be the value? What did you say? When you see PC and you calculate for PCX and PCY, you use your PC will be the lesser value between PCX and PCY. So what's the lesser value? Now, plus what's our MX? 1. What's our capital letter MX? What's our PY? We have to convert this to what? The unit of this is what? Kilonewton-meter. To convert this kilonewton-meter, what do? Just you multiply this times 10 to the power minus 3. What's ZX? What's Z? Elastic modulus. So you go and extract it from your section table. You memorize it. You still memorize it. Don't worry. Your ZX. The lucky thing about this question, if you want to answer it in the exam, it comes alone. Like it doesn't have theory attached to it. So they will ask you, but then you can fail. You can fail now. He can fail. I beg. So now, what's our ZX? Please get your ZX for me. What's your ZX? Ekpele, Ekpele, we're almost done. What's ZX? 1760. What's Z? Elastic modulus. X. Elastic modulus at X. That's 1760. OJB. Totilito. Yes. So now, this check will fail. Yeah, I know it will fail. Oh, yeah, let's continue. So the clause is what? Lesser than or equal to what? 1. That is, your answer must be what? Lesser than or equal to what? 1. And I think I got 1.2. I told you a way to write last week. Didn't I tell you? I told you there was a way to write in this course last week. In your border, you put your clauses and your tables. What? I don't tell you. All right. Yes, now, for everything you are extracting, where is it meant to know that you took your formula from? It's not the teacher because. Okay. Eh. No, just be writing it with it. 1.2, Abi. So 1.2 is greater than 1, right? The check says your answer must be less than or equal to what? 1. 1.2 is greater than 1. So not okay. At this point, you are meant to go back to what? Step 2. But me, I'm going to finish it for you. It has failed though, but me, I'll finish it for you. So that you're going to be doing it yourself. So this is 1.2. 1.2 is greater than 1. So this is not. Who's calling me? Oh my God, please join Idoro's class. Join Idoro's class, so building students. Until you call. That means the turnout is very low. They said it's vexing. I beg, let's join his class. Better shh. I beg you. We are 16 in a class of 70. Kilo day. I beg, just reduce your kilo. You can start calling him like that. Damn it. You know you will ask question. Me, I know you will ask question. You can help us to. Oh, when you mute mic. I muted my mic. Now, the third check you are doing, lateral torsional buckling. Lateral torsion, that's the subheading. You know this one we did is what? Buckling what? Resistance. The third check. Eh? No. The third check. The first check we did is cross capacity check. Cross section capacity check, right? The second one is what? Buckling resistance check. The third one is lateral torsional. Lateral torsional check. Sorry, lateral torsional buckling, Jerry. Now go to table. Please reduce your volume if you're in this class. What step have you got to? I didn't write out these steps for you guys. That's what I'm saying. Eh? 1 times 25 divided by 265 by 589 times 10 to the minus 3. Now, go to table 20. Table 20. What we want to do now is lateral torsional buckling check. Go to table 20. Please, if it's to be memorizing 5 steps of this solution per day or something, please memorize it. Table 20. Hello. You can do that later. We're almost done. You're already tired. Table 20. Are you there already? Where is your table 20? Now, in your table 20, you see a formula that says bending strength PB. Small letter P subscript B. Are you with me? Now, we are trying to find our bending strength PB. Bye-bye. To find your bending strength PB, you need to know your beta subscript W first from that formula. Are you with me? Your beta subscript W. To get that, go to clause 4.3.6.9.
Can you relax?
Sorry. You want to get bending strength. Bending strength is small letter P subscript beta. You want to get that in table 20. But to get that, you need beta subscript W. I've forgotten the name for it actually. Go to clause 4.3.6.9 to get your beta W.
4.3.6.9.
Yes. Calm down, I'm moving too much. 6 points.
I've studied this thing, but
Now, it says the ratio. Are you there already? It says the ratio BW should be taken as follows. Now, when we classified our entire cross section, what did it give us? Class what? Class 1.
yes.
So that's what you use for this one too as well. So our BW will be what?
1.
How will our BW be now?
1.
You are not there. I said go to 4.3.6.9. That's how you get 3.6.9. Now, can you see your BW? 1. Good. So let's go back to our table 20. So this step that we actually want to do is to check our what? Lateral torsional buckling, right? So the first step under this lateral torsional is to get your bending strength, small letter P subscript what? B, from table 20. But to get that, you need that ratio beta subscript W from what? 4.3.6.9. We've gotten that as what? 1. Good. Now, that table 20, hello, that table 20, there is a formula here. Beta subscript W, let me write it for you. Now, now, what did he tell you? That's the formula. So get the value because you need that value to use this table. What's your beta? Your beta is what? 1. Your beta W is what? 1. Raised by what? 0.5. What's your LE? 7,000. What's your RY? 77.7. So what would that give you? 90.09.
I swear, give me one like
90. That's what you got. Me, I just use 90 because 90.01 is still 90. So your answer will give you what? 90. You give 90.01, which is 90. Are you with me?
That's this was very
Yeah, we'll go to 10.
Don't shout, don't shout.
Kilo coin. You did raised to power 0.5 times 7. All of this is raised to power 2. Now, are you with me? Are you with me? Huh? You can probably. What? We interpolate now. What's interpolate? I use 90. Okay, you can. Okay, I'll go give you. You can use 90. You can that one is sensible approximation, not the one that you have 90.5. This is 90.01. It's still 90. So now, let's look at D over T. It says capital letter what? D over capital letter what? T. Look at it now. In that same table, you need to get the value of that as well. I know you look like say you don't understand what I dey talk. Capital letter D over what? Capital letter T. So what's the capital letter D? Your depth from your section. Are you with me? Yes, now from your section table. Then your capital letter T2. You still interpolate. What's capital letter D? What's capital letter D? 314.5. Cap 314.5. What's capital letter T? 18.7. So what would that give you? 16.8, right? We are doing D over T. We want to get the value of this thing. D over T. We have not found our PB yet. We first found the value of this one first. What did we get? We got 90, right? This one, let's find D over T. What will be the parameter here? That's capital letter D divided by capital letter T. Capital letter D from your section table. Your depth of section, that's it. Capital letter T is your width of, your thickness of flange. So what do we get? 16.8. So you have to interpolate to get your PB. Do you understand? Hey, let me be coming one after the other. What do you get? You got 16.8 as your D over T, right? You have 16.8 here. So that will be between what and what? 15 and what? So you know you are doing between these two. What's the value of this? What's the answer of this value?
90.0.
You have 90, Abi. So that means you interpolate between what? 90. You interpolate between 243 and what? 224. Are you there? You interpolate between what? 243 and what?
Did you get me? I know you are saying we interpreted between these two, obviously. But like we got 90 point something now.
Did you get 15 point something?
No.
16? That's how you're interpolating it. 90 now.
Swear I lost like mad.
Yeah, brother.
Big mama, come here and dance now.
I will come. Pick up for them. Carry everything where they do.
I'm not supposed to do between 90 and something.
See the table you went to.
You said they be 20 now.
Table 20 has different tables now. See. Grade S275. You are using 335.
Where's the other table now?
Read this table.
Oh, I swear, I thought it was only one.
Says grade S275 steel, thickness less than 16. But our thickness is what? Our material thickness. The highest between small t and T
Yeah,
is greater than 16.
yeah. Okay.
So this is the table we use.
But that's not my question. That's not my question.
That's your question.
You said that we find D and C now. We interpolate.
No. To find D over T, D over T,
Sorry.
D is 314.5 from your section table. Capital letter T is the thickness of your what? Of your flange. You've taken that. You divide it, you got what? 16.8. Now, do you have 16.8 here? No. So your answer, your 16.8 is like between these two, but you have 90, right? So that means you interpolate between 222, sorry, 201 and 201 and what? 188 to get your PB.
Oh.
Do you get 16.8? In some cases whereby this formula that we did at first, if it not give you whole number like that, you interpolate how many times? Interpolate how many times? Is it twice or thrice?
Yeah.
Yes. Okay, you interpolate twice.
What are you talking about?
In a case whereby this formula here doesn't give us whole number, you know it's going to give us 90.
What's 90.something, man?
Eh?
It was 90.09 now.
Are you with me?
Yeah, that's what I'm saying. 90.1. So it's okay to approximate to 90.
You are not meant to see. I just want to get this thing done. First of all, it has failed. But I just want to explain this step. Hello. Now, we're actually meant to interpolate twice here. I did magu in that place to make it 90. Are you with me? I did magu there to get 90. But you're meant to interpolate twice. The first one within the vertical column. Are you with me? The second time is within the horizontal column. Are you with me? So you interpolate 3 times, not twice. Do you understand what I'm saying? All right, see people are leaving one after the other. I don't even know. Maybe I told you 3 people, bring it. So now, if we get 90.1, right? Our 90.1, you know, this D over T give us what? 16.8, right? Where's your pen? Sorry. You got 16.8, we got 90.1. 90.1 is around here, right? Between these two. Now, for 15, you know, we still have to interpolate between 15 and 20 here. For 15, we interpolate between these two to get the value for 90.1. For 20, we interpolate between these two to get the value for this one. So for 15 point,
Which one?
for 16.8 that you got in this D over T, you now interpolate between these two values you got for 90.1 to get the actual value of PB. Do you understand what I'm saying? So you interpolate 3 times. Should I come again? That's why I said you interpolate 3 times. Eh? You say what's my final answer? Let me explain to you. Wait, what was your answer? 90 point what? Stop it, stop it.